Hello students, today we're going to look at partial fraction decomposition. It's a way of finding integrals such as the one I have here on the screen. The idea is that this integral itself is a little bit difficult to find the antiderivative of, but what I want to do is, if we notice that the denominator factors, and all polynomial factors, denominators will factor, what I want to do is I want to take that polynomial 3x minus 22. I'm going to go ahead and factor the denominator. Clear that up there a little bit. 3x minus 22 over, I'm going to go ahead and factor the denominator. It should factor as an x plus 6 and an x minus 2. Positive 6 and negative 2 multiply together to give us the negative 12, and they add us to give us 4. So it's going to factor like that. What I want to do is I'm going to rewrite that as something over x plus 6, a constant divided by x plus 6, plus another constant divided by x minus 2. The idea is that something over x minus 6 and something with linear factors down here on the bottom is far easier to find the antiderivative of. It's actually fairly easy to find the antiderivative of that thing. So if these two expressions are going to be the same, what should happen is, if I get a common denominator on the right hand side, I'll multiply the first one by an x minus 2 over x minus 2, and I'll multiply the second term by an x plus 6 over an x plus 6. Alright, and so then I have the numerators are the same and the denominators are the same. So if these two fractions are going to be equal, then their numerators have to be the same. So 3x minus 22 has to equal a times x minus 2 plus b times x plus 6. And if those two are going to be equal, they're going to be equal. So the way I like to think about this is I then continue to multiply those out. I'll have an ax minus 2a plus bx plus 6b, and that's equal to 3x minus 22. And so what I have are two polynomials. I have a 3x minus 22 equals a plus b times x plus a negative 2b, negative 2a plus 6b. And these two are polynomials, and these two polynomials should be equal. And if those two polynomials are going to be equal, that means that the coefficient of x has to be the same in both, and the constant piece has to be the same in both. So 3 has to equal a plus b, and negative 22 has to equal negative 2a plus 6b. And that's a system of equations we can solve to find what a and b are. And this is actually a little bit long way to do this. There's actually a little bit of a shortcut, a quicker way to do it, but this is the way that makes sense to me. And so we're going to start with that, and then we'll come back with another example. We'll do a little bit faster method of doing this. So let's see. So what I can do from the first equation is I can solve for a. A is equal to 3 minus b, and then I'll go ahead and just substitute in over into this other equation. So negative 22 is equal to minus 2a plus 6 times a 3 minus b. And so that's a negative 22 equals, whoops, I put that in the wrong spot. I'm replacing a with a 3 minus b. Alright, so I'll get a negative 6 plus 2b plus 6b, and so I'll get a negative 22 is equal to negative 6 plus 8b. So if I move the 6 to the other side, I'll get negative 16 is equal to 8b, so it looks like b is negative 2. And if b is negative 2, I know that a is equal to 3 minus b, so a is going to equal 3 minus negative 2, so a will equal 5. And so what that means is I can come down here, and the original integral I had was, I was trying to find the antiderivative of 3x minus 22 over x squared plus 4x minus 12. What that means is that's the same as finding the antiderivative of 5 over, oh, I got to go back and peek here real quick. I said a was the x plus 6. So 5 over x plus 6 plus negative 2 over x minus 2 dx. And those are integrals that are pretty easy to do. The antiderivative of 1 over something, you can do it with a substitution if you want to, but I think this is one that we're pretty clear that if you've got 1 over x, the antiderivative is the natural log, and so what I'm going to get is 5 times the natural log of x plus 6 minus 2 times the natural log of x minus 2 plus c, right? Because the derivative of the natural log of x plus 6 will be 1 over x plus 6 times a 1. The derivative of the inside is just 1, so the antiderivative of like 5 over x plus 6 will just be 5 times the natural log of x plus 6. But there's our antiderivative right there. So that's a quick, nice way. You get something that's super easy to find the antiderivative in most cases, and so it makes it easy to find that antiderivative. Alright, I'm going to end this video here, and I'll do another one with another example.